Hello everyone. This is our day 3 for the workshop Intro to Unix, and this workshop it's our final session. I think we have gone through a lot in our previous 2 days workshop, and this time we are going to talk about the shell scripting and especially how to run the jobs on Hopin 2. So as usual, the rotation of the slides stays the same. So the line with this arrow will be just a code chunk. You can copy and paste. And if you find some super link in this slides, it will shows in this underlined text. And we also have some practice for you guys to play with. It will usually come with this little element. So for our previous, it's mainly about the Unix command line, and we know what the file system looks like in the Unix. We know how to go from one direction to another direction, and directories, and we know how to do the create, delete things on the files or folders. And we also have experience with those set AWK grid. And so today, finally, we are moving on to the shell scripting, trying to do some programming things today. So as usual, we will have a 10-minute break after 45 minutes workshop. And from time to time, we will experience a lot of practice, and I will pause there, give you some minutes to finish the tasks, and later I will just try to maybe demonstrate how to do that and also answer some questions. So today's topic is about programming. So first we are going to learn the variables, like if we want to define our own variable, and also some operations on the variables. Next, we are going to learn some kind of structure in programming, like the conditional statement, like if-else statement, and some repetitive statement, like the loop structure, the for loop, while loop, or something. And lastly, we will submit jobs to Hopin 2 cluster. So for the quiz, so for those of you who take this course towards credit, you take this workshop because you enroll in a course. So you are required to finish one quiz and one assignment, and the quiz will be released today, probably in the afternoon, and it's due in 1 week, and the assignment will be released tomorrow and also will be due in 1 week. Okay, so if you are not taking this workshop for credits, you are still very welcome to finish the quiz and the assignment, because the quiz is like it's just multiple choices, and also you try to fill in some blanks. So it's kind of like helpful for your reviewing the course materials, and the assignment is trying to give you some practice on what you learned. So if you are not taking it for credit, you are still very welcome to finish that. And the questions for today's questions, you can just click Google Doc and paste it there. And if you feel okay and you are confused about what's going on with your computer, you can put a picture there. So I will go over the questions at the end of the workshop. And if you have quick questions, you can also post it on the chat room on Zoom. So I want to start by summarizing what we have learned in day 1 and day 2. So basically, we have knowledge about the Unix file system and how to navigate through it. So we know how to manipulate the files and directories. And we know some advanced commands for the file processing. Like if you want to view the file, you can use cat, nesmore, and head and tail, and so on. We also learned the seed, AWK, and grep to try to edit like the file, or just print a certain column of the file, or trying to search a specific pattern of the file. And lastly, yesterday we learned what is the regular expression and some basic knowledge on how to write a regular expression. So besides this knowledge, we also have some experience about how to access Hofan2, how to do the file transfer between your local computer and then the remote server. And we also have experience on how to request how to request the resources on Hofan2. And we also talked about a very useful trick that you can combine different commands with using a pipe to finish all the scenes in just one line. All right. So specific about the commands for navigation, we use SH to collect to Hofan2. And after that, we use exit to close the collection. And if we want to know where are we can use pwd to print the current working directory that you are in. If you want to go from one location to another, you can use cd, and ls is trying to list the contents in this folder, or list some information about the files. All right. So for the file and the directory manipulation, we know how to create things, directory and file. We know how to delete using this remove command. We know how to copy one and move the file from one location to another. And we also know how to get the contents of the file using cat, how to modify using vi. And we also have gone through the permission, file permission using change mode. And for the decompressing, we use gzip and tar, and also file transfer, we talk about two command. And also there are also some GUI applications that you can do by just clicking your mouse to do the file transfer. And because there are like, as you can see, there are thousands of command lines. So we are not like expect you to memorize all those things, and especially each command line, they have a different flag options. So it's hard to memorize all those things. So we use the man or this double hyphen help to give you the hint about how to use it. So if you run it, and then you probably will see, okay, the usage and what's the meaning of each flag. So basically, you can always rely on these two things to help you remember things. Okay, and for the file processing, we have talked about cat, how to extract the contents of the file and print to the standard output. And then we can also use cat to merge files. And for the just viewing, we can use more or less to show the contents. And if you're just curious about the very beginning or very ending of the file, you can use head or tail. And still, there is another version about showing the contents with the compressor file. You use zcat, zmore. And after that, we talked about the sort, how to sort the file based on one column, and some kind of like the redirect the output, standard output to a file to create a new file. And this magic pipe thing will combine commands for you. And we also talk 4 different commands: word count, try to count the number of lines or words, card try to split the string into two different fields, and you can take one and you leak to deduplicate diff, trying to compare the difference between files. And lastly, I think this one, the C, the AWK grep, is more advanced content. So I will always encourage you guys, if you are going to use those things, trying to refer to the previous slides, check the examples we have done in the class, and then try to like follow the example, write your own by just copy and then modify, make it specific to solve your questions. So seed is just editing. AWK is trying to parse the text and then do some processing, and grep is trying to find a pattern. All right, so we have learned a lot in the past 2 days. And so today's, so first at the very beginning of learning something, I always want to give you guys some motivation for why do we need to learn those things. For example, for the command line, because we want the computers to do some tedious work for us. We want the computers to process our data. So that's why we learn command line. But for today's topic about the shell scripting, is that the command line is not just a lab. For example, a computing task can consist of multiple steps. For example, on the right-hand side, it's an example for our RNA sequencing analysis. So first, we want to do some, after we get the sequence, we want to do some quality control. And then we want to trim the adapter and filter out the low quality read. And after that, we want to do the alignment and then do the gene expression quantification. After that, we can get a table. So basically, this process contains multiple steps, right? And we don't want to, wait each step to finish. Instead, we want to combine all the steps into one step so that we can just run one single script or one single procedure to finish all of them. So so this cannot be done just using the command line, or but it's more like convenient if we do it in the shell scraping way. And another thing is that maybe you should run those procedure multiple times. For example, you have a batch of data this month, and then you need to do it in this way. And maybe next month you have another batch of data. You need to do it again and again. So these tasks can be done repeatedly, right? So but we don't want to like type in the commands over and over again, right? It's kind of like a waste of our energy because we have done it once, so we don't want to type in every time we need to run this thing. So probably we can just find what we done before and just use those procedure and this time, right? We finally just want something to automate the tasks for us. So I think this is kind of an example for working hard, that you type in multiple commands by your hand and repeatedly, and working smart, that you just using the shell script to take care of everything for you. So the shell scripting is kind of like a programming we're doing, and basically we can just categorize or just make it into 3 steps. The first one is trying to create a shell file, end up with .sh, and we can use a VI editor to do that. And in this workshop, we are mainly using the VI. There are also some other text editor like Nano in Unix. If you are interested, you can check it out on your own. But for the workshop for our workshop, we will just use VI. And then you can write down your commands or write down the line of code, and then save the input into this file, and then you can execute the commands in the file. So so in this way, you have all the things like multiple steps just stored in the one file, so you can just avoid the repetitive work. So if you want to run all of those things, you just run this file. So you avoid those tedious typing work for you. And so first, let's just do some preparation that you can make sure you collect to the Hofan2 using this SSH command. And then you request an interactive load by running this QRSH command. And we have done this before in our very first day. So if you haven't have this QC bio folder on Hofan2, you can just copy this git clone to your terminal and then try to work from there. So this is just the preparation work we have done before. So today I think probably you just need to SSH and request an interactive node. And after that, we can, using the VI editor, to create a new file called hello.sh for us. So still, I just want to remind you about the usage of VI. So first, you press I to enter into the insertion mode, and press escape to jump out of them. And after you finish typing, you can use this column WQ to write and quit. And so this is like, just also another preparation step for our very first shell script. I'm going to introduce you about the echo command. So basically it will print the string that follows to the standard output. So when you do echo hello world, it will print the message to the standard output. You can also put some flag to that. For example, if you if you don't want another line, you can use this -n, so it can it will not generate a new line. So here is an example I tried previously. I do the echo with a string, the current time is, and I use another command called date, which will print out the time on your system. So basically, we can get the quick sense what time is it, and if we use the echo -n, so this will not generate a new line for the date. Instead, they will print out into just one line. And also, there is one thing to notice that I use a semicolon here. Basically, it's just like trying to run two command at one line. So you can just try typing those things and see what the results look like. So finally, we are going to enter into writing our very first shell script. So as I said, you can use a VI editor, VI hello.sh, and then enter into this file and input those things. So basically, I will just explain what does each line mean. So for the very first line, with the pound exclamation mark, and with the back this /bin/bash. So basically, you can just follow this one. This just tells the interpreter where which shell you are going to use, right? So usually you are encouraged to specify the shell with in this first line. So just copy and paste, just type in those exactly. And the second one is just like with a started with this pound. So this is just a comment. So comment usually will be ignored when executing it, but it helps you a lot to understand what you have wrote in this file. So this will be just a way to try to let you understand what you have done, right? And if you are going to use a lot of commands in the file, I always encourage you to add comments. For example, you should remind yourself, okay, what I'm doing here, this, why we do it here, or just write some kind of like README specifying what's the usage of the script or something. So I always encourage you guys to write some comments to help you understand your code. And the following three, the echo thing, it's just the code lines. So when you execute the shell script, you actually will run the command line by line, right? So I think probably you can just try to type in those things, and after that press escape and save the file using this column WQ. So after that, we are going to execute our very first shell script. So here is just one option that we can use dash hello.sh. So after that, it will print, okay, the first line, hello world, and then echo the second one, that is from, because we use the -n here, so it will not have a new line for the third one. But here for the third one, the $sign user, actually this is a variable we are going to teach next time. So this will just print the string of my username. So this is for the option one. The option two, as we have talked about at the day one workshop, that actually we can grant the execution searching permission to the hello.sh, right? So this is just like what we did before, like using ls, this non-list form, and we can change mode, grant it with the execute permission to this file. After that, we can use this ./hello.sh to run this whole script. So basically, this dot here means your current folder, and this is just trying to denote the location of your hello.sh, and just directly run it. So you can also try to use the absolute path to denote the location of this hello.sh. Here, I think probably you can just try to use a /. Yeah, so maybe I will give you guys the maybe 2 minutes to let you finish the typing and then try on your own. Yeah, so this time you can just follow the previous slide to finish the task. So I'm not going to demonstrate you how to do that. And the next, we are going to talk about the variables. So previously we have seen that we use this $sign with the capitalized user. Basically, it will echo a username of your username. So this is actually a variable, and specifically, it's an environment variable. And besides that, environment variable is more like some variable that defined by the system, and you can just call it. And sometimes we want to like DIY over our own variables. I just here call them as the user variables. And so with the variables, we actually can do something fancier. For example, we can perform some operations on the variables, like we want to do some math with the variable, and we want to do some like string matching of the variable. And also we can assign the command output to a variable. For example, sometimes you just want to list all the files in this folder and then save the output into another variable, so that you can just like in a for loop, you can iterate each file and then perform some operation and then move on to the next file, perform the same operation, something like that, right? So another thing is that we also want, so previously we didn't pass any parameters into our scripts. So it's sometimes it's desirable that we can pass some parameters to the scripts, and the scripts can accept it and then use it in the following code lines. So we are also going to learn this one. So for the very first, we want to have some impression about the environment variables. So basically, there are a lot of environment variables. Here I just listed some of them. For example, the user will be your username, and the host name is like the server's name, the login one here. And probably you are in login 2, so if you echo that, it will tell you your current load. So here, echo actually have a good way to show the contents in the variables. So if you do the echo, it will print out the value of this variable, okay? And if you echo home, it will print the path of your home directory. And if you echo pwd, it will print your current path on the current path, the path of your current directory. And the path here are the absolute path, that is right from the very beginning, the slash, the root to the folder. And you can echo bash, it will print out the shell. And if you echo the path, actually it's kind of like the passes to your commands. So basically, I will talk about it later, but you can see that there are a lot of strings or passes here that is like collected by this column, right? And actually, when you type in some command, it just searches all the passes and then find that command. So if you so one thing I want to mention is that you can notice we always use the $sign before the variables. So this will means we want to get the values of the variable. Okay, if you don't use this $sign here and just use echo user, probably you will just treat user as a string and it will print user. So basically you can try on your own that you remove this $sign, see what it happens. Okay, and you can also use the echo to print the value of variables, and you can also use set to check what the environmental variables. I told you there are a lot. So here is just like some examples I show. And another thing I want to mention that when we define a variable, it has some scale, effective scale, that it has some scope. The environment variable can be like treated as a global variable. That is, whenever you are in this environment or you are in a shell script or something, it can always be referred. Like the value should be always accessed in what kind of situations. So those are the global variable. And if you are defining a variable by your own, and usually the variable is only valid in your script. So those are called the local variable. So yeah. So previously I talked about the path. This is just like the different passes we collected using this column. And here is just a very small questions that have you ever considered how how the Unix system recognize our commands? For example, when we type in something, it will just directly return the output of this command. But when we try to type in some command, something that is not a command, they will tell you the command not found. So it's kind of like how do we distinguish, okay, this is a command, that is not a command. So this question is actually related to the path we have talked before, that it will first search this state, this command in all the passes, right? So if you use which state, it will print out the path to this command. And if this command is not in this path, so it will tell you low DATTT. Here I just randomly created something, right? So they are not found in all the paths in all the passes, right? So this actually solves our questions that Unix recognize our command by internally searching this command in those passes. Okay, and also actually, as we have mentioned before, the Unix treat everything as a file. So actually, the command here is a file. So here is just what I tried. I just listed the command here, and we can see that okay, it's a file and it has executed permission. I hope these slides can help you understand how Unix system works, especially when we type in something. How does it decide this is a command and this command is not found? And those are about the global variable. And the next thing is a user variable that usually we want to define some variable on our own. And this syntax can be quite easy, so basically you just put your variable name and with an equal sign and with some value, okay? And just remember that this is kind of different to other programming language. Probably in other programming language, you can put spaces like before and after this equal symbol. But here, the shell is very particular about the format especially there, if you put spaces, it probably will run into error. So just make sure there is no spaces before and after, okay? And here I just listed several type of value that you can choose. For example, if you want a numerical value, just put the number here. And if you are going to define a variable with string, you can use a quote, single or double quote. Usually single quote is preferred. And then if you are going to use an array, that is more like something like a list in Python or something. So basically you can use this parentheses to include everything. And also remember that we will have spaces between each element. So as I said, that shell is kind of the bash shell scripting is kind of particular about the spaces. So always try to remember when you should use space or when you should not use space. Okay. Okay, and yeah, we have underlined the importance of spaces in shell. And also here I want to remind you that the shell is kind of case sensitive. So this one, the capital V variable one and capital variable one. So basically those are two variables. So this this is also important, like case sensitive in our commands. So basically if you use capitalize the S and small the capitalize the SH. So basically if you put into that, it will tell you, okay, the command is not found. So the command is also sensitive, case sensitive, and the variable here is also case sensitive. And we have talked about we can use a $sign to refer the value of the variable. And also when we define our own variables, we should always avoid give it a name that is it's the same name with the environmental variables. So one thing you can do, try to do this is that you can always try to name your own variable using the uncapitalized letter. As we have seen before, that the environmental variable, they usually start, it's the capitalized letter, right? So to avoid some confusion, you can just simply use an capitalized letter to name your own variable. And also, you don't need to declare the data type when assign the when you try to define a variable. So this is not like the C language where we learning. We must declare the variable type if it's an int, if it's a string, if it's a char, right? So at that, we must declare those data type beforehand. But here, we don't need to do that. The syntax is really simple. And you basically, the shell basically will automatically assign the data type for you based on the value you input. And we have seen a global variable before, that the environment variable is usually global. And here, the scope of our user-defined variable is usually local. Okay, and that means after, like when you exit this shell script, probably you will not find this variable to be defined. It's only useful in this file. Outside this file, you need to redefine it. Okay, probably I think it's time to take a break. We will give a 10-minute break, and during this break, you can simply try those things. It's really easy. Maybe take 1 minute to finish. So we will take a break here, and I will see you after break. So I will share my screen on how to solve this issue. Let's see, this one. All right. I will just do a quick demonstration for the practice tasks. So we cd into day 3, and the first task is trying to print those environmental variable. So here we are using the echo with a $sign. The $sign will try to refer the value of the variable. So always remember to put the $sign here. And because this, maybe we can just run it first. And because the shell is it's usually case sensitive, so maybe this time I just change the last E to the capitalized format. So we will see it will echo nothing. So this is because this one is not defined. So always remember that the variable name is case sensitive. You can capitalize something or capitalize something, probably you get very different results. And another thing is trying to do the assignment to a new variable. So we create a variable 1 with this equal sign, and we assign 10. And always remember, we shouldn't put spaces here. Okay, and after that, we can echo this variable, and still because we are using the shell, we can always use the tab key to do the autofill for us, right? Okay, so it will output the value of this variable. And so I actually got a very good question from the chat box. So actually, if we do this, we put a semicolon here and echo this variable, we will get 10, right? But if we do a pipe in the middle and echo this variable, we will get, I think maybe I should do another way, like give it a new link. So this is because we already defined a variable 1, so it always can print out the same value. But if we do in this way, it will print nothing. Okay, so the reason is the difference in this semicolon and the pipe. So basically, this semicolon is trying to it still treats the two commands as two. So it will run this one first, and then run this one second. So it's just like we run this one, input this one, press enter, and then input this one, press enter. It's something like that. So the semicolon here is nothing but just try to run two commands sequentially using one line, okay? So this is the semicolon's usage. But for the pipe, it's actually, these two things are one command. So basically, that's the reason why we define this thing. And but within the current environment, this one still think this variable is not defined. But after that, this variable is defined. So I don't know if I make it clear, but the pipe here treats the whole thing as one command, okay? But here is actually two commands, and two commands. So the first one, it defines variable 1. The second one refer to the value of variable 1. But here, because this is just one command, when you refer to this variable 2, it actually has no like. So when you define this thing, it actually it's not yet in the environment. So when you refer to it, it will tell you nothing about that. So one thing we should be cautious about the pipe is that we only want to use a pipe when the very first one's standard output is the input to the second one's command. So you only want to use it in that way. So remember that if you just want to run two commands sequentially in one line of code, you should use this semicolon. Yeah, I hope that explains the difference of these two things. And if you still have questions, you are free to send me the another question in the chat room. And the third one is what I designed, trying to get you guys familiar with the concept of spaces. So for example, if we define variable 3 with a space here, okay. After we do that, it will tell you the command is not found, right? So when you echo this thing, it will still output nothing. So this is just a demonstration of how the shell is particular about the spaces. So always try to remember when you should put spaces or when you should not put the spaces. All right, this is about the variables. And next, we are going to learn the operations on the variables. So the operations on the shell is kind of limited, but it's still, you can use it to do a lot of things. So if you are going to do very fancy operations, like you want to define some kind of math function, you probably should choose other language like the Python, so that you make your life easier. But here we still provide some simple solution to do some simple operations on the variables. The first one is like the numerical operation that we can do the addition, like the minus, subtraction, divide, or time, or get the residue, right? So here the syntax is fairly simple. We use the $sign and use two brackets wrap around this operation. For example, we want to take the like 2 times of variable assigned to another variable. So here, always remember when you try to refer the value of a variable, you always need to put this $sign. Okay, if you don't, you will just merely treat it as a string. Okay, and so another thing is that the output will only be in the int format, that is integer. Okay, it's not a float. So here is an example I tried before, that I actually do this thing to variable 2, and then after we finish that, we can see the value is actually the twice of the variable 1. And besides the numeric operation, you can also do the string operation. The syntax is looks like this way. You put a $sign parenthesis, wrap around the middle part, which is the EXPR, stands for expression, and then you can put your operations here. For example, if you want to take the length of a string, you can use length this string, and also remember they are separated by the spaces. Okay, and there are also some other operators I listed here, and I'm not going to go through all of them, but you can check the description about each operator. So yeah, it's fairly straightforward. And here is what I tried for this command. You simply just do this, run this line of code and echo it. It will tell you, okay, the banana has 6 letters. So basically the length is 6. And for more information about the EXPR, you can check the Bible book for some numerical operation. So I'm not going to go into so many details here, but I think the basic operations should be useful and satisfy our basic needs when dealing with the shell in daily routine. And we also have another kind of variable that is an array that we can refer to, like the nth element of the array. So this one is actually like if we want to refer to the nth element, we should put this $sign, the carry bracket, and then we use this array name with the bracket n-1. So n-1 is because in this array, the index starts from 0. So if you want to refer to the first element, you should put array 0 here. And if you want to refer to the nth element, you put n-1. And if you want to print out the whole array, you simply replace the middle part as an @ So this will print all the elements in the array. So this is the example that I tried before, that I define an array. And if we just do do the echo of the array, it will only print the first element. So this is something you should remember, that if you just if you are dealing with the array and you want to print the whole thing, you should always try the second one. And if you want to refer to the third element, you should use 3 minus 1, which is 2 here, and you will print the third one. So this is like the reference operation of array. So probably is another time for us to do the practice. I will give you maybe 2 minutes to finish that. Okay, I will, because the next one is kind of just to repeat what we did in the previous slides. So I will just show you this one. So first, still we assign 10 to variable 1, and assign maybe 15 to variable 2, and we want to do the variable 1 variable 2 over variable 1. Let me check if my syntax is right. Yeah, the $sign. Okay. Oh, yeah, I should put $sign for each variable. And then we echo variable 3. It will only give you 1. So do you guys know why this would happen? If you have answer, you can just feel free to speak. Okay, so maybe I just directly give the answer. So as you can, yeah, I think that I got one. Okay, yeah. So we have an answer from the chat box saying, okay, it's int. So exactly because we have talked about this before, the output will only be int format. So basically, we supposed to get 1.5, right? But here, because we only use this simple syntax here, we just trying to get the int of that one. And if you really want to get 1.5, I probably will suggest to check this Bible book using the expression operation. It will give you a more complicated numerical operation there. Here, I just want to use this example to show the int output for the numeric operation, simple numerical operation. All right. And for the variable, another thing I
have a question. Would you be able to repeat the previous example with variable number 2 being 1?
Oh, variable 2 being 1. This one?
Because you gave it a value of 15, but could you give it a variable 2? Can you give it a value of 1 and then do that operation again?
Yeah. So I think yeah, it's quite easy to try. Probably we can, yeah. So every time when you feel you need to demonstrate something, you can always try on your own terminal. But here, I think it's good time to try and see this, right? And echo 3. So here I use the up and down K to go to my previous command. So this time you will get 0, yeah, because 1 divided by 10 will give you 0.1, but because we only keep the int part of the results, it will only show the 0 here. Right.
Got it. Thank you.
Yeah, sure. So yeah, thanks for raising up this good, interesting point. So another thing I want to talk about is trying to assign the command output to a variable. Actually, you can do it with two options. One is trying to use the backtick character. So basically, you just wrap the commands around with two backtick characters. Or alternatively, you can use this $sign with the parentheses to do that. So here is what I do. So for both of them, let's just take a look at the option 2. So basically, we want to list the job. Remember the wildcard trick we talked about yesterday, that it will print, will only list all the files that has a job in the middle, or any file that have this string, this substring. So in this way, we can list them, which will assign the output to an array, to a new variable. And the next time we echo this array so that we can see what the values in this array. So all of them contain this job string. So this is actually a example for the assigning of output to the variables. And next is about how to pass some parameters from command line to the script. So here it's example that we actually can accept from the terminal some parameters to the script. So for example, here I use a $0, which is the default. The $0 is a script name. $1 is the first parameter. $2 is the second one, and so on. So here is an example I tried that I just trying to pass this parameter and this parameter to the script. So as we use the echo to print out the values, so we can see, okay, the first parameter is param1, which is the first parameter here, the apple, and second parameter is banana, and the script name is what does this script is called? It's a pass para.sh. So this is the example for how to parse some parameters into your script through the terminal. I will give you guys maybe 3 minutes to finish the practice.
Hello, can you repeat the previous slide? Yeah, where does the apple and banana comes to the parameter? So $1 means what? The first parameter?
Right.
And in your bash, does that assign the first parameter?
No, the apple. Can you sound the sound?
Your voice broke up.
Okay. So this apple and banana here is just a string that I put into this script. So this apple is our parameter 1, banana is our parameter 2, right? So basically, they are just strings. You can simply put everything you want, maybe 1 or 2, some numerical value or some string. So basically, this $1 is like the default to accept the first parameter, and the $2 is the default to accept second parameter. So you simply use them and assign to the new parameters here. And the script name is the $0, which is just the script name. Okay. So when I accept the parameters, I just store them into these new variables. And then I want to know what's in these variables. So I echo them and print out, okay, the first parameter is par1, which is just the like $1, and it's apple, okay? And the second one is a banana. So the second parameter, and script name is just this one. Does that make sense?
Got it.
Okay. So another question: why don't you have to use quotations for the strings? So yeah, this is kind of tricky. You can also put it, but it's okay in that if you don't have a like the string, it's like a whole string. It's instead of some kind of words with space, you can always just put apple here. Yeah. So basically, it's an option. Okay, I will give you 3 minutes to finish this. And if you have questions, you can ask me in the chat box or just unmute. So for the first one, it's very similar to what we did here. Okay, you just simply replace this star job star, just replace it by a single star. And then you can print all the file for the names. Okay, so for the second one, I'm going to show how to do this one. We want to write a script that accepts a file name and print out the file name and the file contents. So this time we will just create a new file. And after that, all right, we always trying to get the first line as the bin bash because we are going to use bash, and we want to accept the parameters like as a $1, and so next thing is trying to, so the first line is trying to accept the file name, and we want to print out the file name and the file contents. So how to the print out the file name is kind of simple, right? We just need to echo this parameter one. And how to do the file content? So basically, we will use a cat parameter. Cat this file is okay. But here we got a little tricky thing. That is, how can we refer to a file like using what path to refer to this file? So basically, we can use this. We can try this relative path, but alternatively, you are always recommended to use the absolute path. But here, I just first try this one, and let me see. So we can see what's inside the job. Okay, sample 1 to 5, and we can run this test sh. Good. Okay, it seems like we got a little tricky thing. That it cannot recognize the dot here, but that's okay. Let's just try to do it in this way. We can batch test the sh, just trying to put the absolute path before our file name. Let's do, okay. It will print out the names, the path to the file, and then cat the contents, show the contents within this file. Okay. I hope this can be a good example to demonstrate how to do this second tasks. Okay, now let's move on to the next. So the next is going to be the conditional statement. We can use, we are going to talk about this.
Excuse me, sorry. I had a question, sorry, about the last example you went over.
Mm-hmm.
Did you end up replacing the period slash with something else to print out the path?
Which one?
In the script.
Uh-huh.
I just missed that.
Oh,
because
yes.
when I tried to I just used the file name. It didn't. Oh.
Right. So in the previous attempt, I used dot slash to refer to this file. It's because the shell script doesn't recognize that relative path. So here, when we pass the parameters into this shell script, we just add the absolute path. So this is like the code we do. But when we do running, we actually use the absolute path to this file. So this will tell the shell script where the file is, and then it will print the lane and then print out the contents of the file. Does that make sense?
Yeah, thank you.
Okay, yeah. So here it's rather simple. We just accept that, echo the name, the path to the file, and then just get the contents of the file. So if you still have question, we can maybe put some questions on the Google Doc. We will go over that after we finish the session. So for the conditional statement, we were going to teach about those things. So this is a kind of a example that we are going to experience every day. For example, we probably will tell our friends that if tomorrow is sunny, I'm going to the beach, right? And otherwise I will stay home. And we can also do like the if then. So the second one is the if then, and the rest is like the nested if then, like if it's sunny, if it's rainy, otherwise. So we have multiple if else in this statement. So the if condition can be shown in this way, that we actually judge a condition. If it's true, then we run another chunk of code. If it's false, we skip this part. So this is just a syntax of our if then condition. And here the command here is actually a command that will return true or false. So additionally, you can just using this the brackets with the space and with a condition with space with another brackets. So so this should be reminded. Remember that we should use space before and after the condition, and then wrap around brackets. So this is an example I show here. If then condition that if this variable is less than 2, we will echo the value is less or equal than 2. So after we run it, it can get this output. So all the examples is in the folder example underline sh in day 3. So you can just go there and check the code, and probably you can just run simply run it using bash if then sh. And if then else condition is similar to if then condition, and we only need to put another chunk of code. Like if it's false, we run another code. So the syntax is looking like this. And here it's what I tried. So very similar to the previous one, we just use else, the echo, the value is greater than 2. And remember that for the very first, it's like the if command, the condition. And for the last is fi, which is just the reverse of if, right? So this will be the end of the if condition. And after that, we run it we can see the second one. Second statement is run. And we also can do in a more complicated way if then nested condition. That is, so we go through from the start, we go through one condition. If it's true, we do something. If it's false, then we go through another condition statement condition. So if it's true, we do something. If it's false, we go through another thing. So basically, this is just like in the nested way. So at every like branches, we can do a if else. So okay, so this is another syntax. Like if you are going to do a lot of complicated if then judgment, you can do it in this way. That if something, then if it's the answer is yes, then you do this command. Otherwise, you do another round of judgment and then execute another thing. Otherwise, you do another round of judgment and so on. So this is like the example code that I try to show here is that if we do several rounds of a comparison, if it's equal to 1, then we print the value is 1, and so on. So here is like what I tested, that the value, if we put 4 here, so when we run this, when we do this judgment, the answer is false, it's not equal to 1, then we jump to the following judgment, it's not equal to 2, so we go to another judgment, it's not equal to 3, so finally we will end up with else this statement here and echo this one. So there are some like the numerical comparison. If then we can use, we probably have seen this equal before. If we want to do the comparison, we can do -eq, which means equal, and GE means greater equal, GT means greater than, and also for the LELT, it's just a less than or less equal. So for NE, it's like not equal. So it's just like the first letter, okay? First letter of two words. So this is like the numerical comparison in the if condition. And we also have some like string comparison. Like, so this should be, keep in mind that the equal symbol is in the string comparison, and the numerical comparison, you should use this one. Okay, we have equal, that is we try to judge two strings are the same. If it's not equal, we can use put an exclamation mark here. And here the greater or small, less than. So basically these are the like judge the length of the string. And if we want to judge if a string is empty or not, we can use the -n, okay, or -z. And also this is for the string. Sometimes we also go through some existence issue, like we want to judge if a file or folder exists or not. So we can use the -d, which trying to check if there is a existing a file or not. We can also use E to check if a file exists. So this is about the conditions in the if-then statement. And the next thing is trying to do a more complicated way that you have several conditions and you want to combine them together. So this and will show, okay, only when those two conditions are both satisfied, then we can run the following command, the then command. And this double vertical line here is trying to say, okay, if one of them is satisfied, then the total syntax, the total formula is true. So we can run this one. So here is what I tried, and the output that we have this variable defined to be 3, and if it's greater than 2 and less than 4, then we will print this string. So actually, after we run it, it successfully run according to our expectation. So probably I will give you guys 2 minutes. Actually, we can take a 10-minute break here, and then after that, we will go through the rest of things. And in the meanwhile, you can try these 2 tasks. So as you might have find that there is a folder called the example_sh, where I put a lot of example code for each of the structure we go through. So for the first one, we want to create a nested if-then script to finish the following tasks. So here, I will use this one as a template. So maybe I can just copy this one to the outside of the folder, the nested if, and then edit based on that. So when you face the similar tasks in your real life, you can always go back to those example scripts and then try to modify from that. So first thing about this task is that it will accept some of the input from the terminal, the command line. And then I'm going to, so this is called that we are going to use, we're going to have to pass some parameter to the script. So it says, okay, if tomorrow is sunny, then I will go to the beach, okay? So this will, the first one is trying to judge if it's sunny, okay? And then we will print, go to the beach, all right? And for the second one, if it's not, so then we will judge, is it raining? Then we will print, wash my car. And otherwise, I will just stay home. So we will no longer need the third judgment, else if, but just otherwise, which is in this else statement, we will print stay home. Okay. Okay, now let's check if we can get it run successfully. So we will use nested if and input sunny. Okay, then it will print go to the beach as we expected, right? And if we put rainy, it says, okay, wash my car. And if we if it's cloudy, it will say, okay, stay home. So this is exactly what we try to finish following the description. Okay, I hope this guidance can show you, okay, you can actually use the example script to finish some tasks for yourself. Just try to make a copy and use it as a template and then modify it to finish whatever you want. And for the second one, it's trying to create a script that can check if there is a file called test if the txt. So basically, maybe this time we will just, okay. Yeah, maybe I can create another file to that. So still for the first line, we use the bin bash because we are going to use bash. And we are going to check if there is a file called the test-if.txt in D3 folder. And to do that, we can go over this one that we want to test if a file exists or not. So we are going to say accept the folders link. So we're still going to accept a path, like the D3 path there. And then we're going to use an if condition, trying to test if a file exists. So this one. And then, what would it do? Okay, if it exists, then we will print a message. Echo file exists. Else, because we want to create an empty file called test, so we will do touch, maybe test. Yeah. So probably I can do this. We will accept 2 parameters. Parameter 2. And at the end of the if statement. So after that, we can check test 2 and the write. So this will be the D3 folder. Let me check the absolute path. Right. If D3 folder test if the txt, and then so this is the first parameter we put into the script, and if it doesn't exist, we want to create a new empty file called a test. So we are going to put that in our second parameter. Okay. So yeah, let's see if it's okay. So as you can see from our D3 folder, there is no test if txt file here. And it is supposed to create a new file called test. And here it is. So it successfully got it created. So we can compare the previous and after the command is run. So here the test file is not existing in the previous one, but here we create a new one. So I hope this command can take you, this script can give you some hint about how to solve this problem. And yeah, maybe you can take a screenshot about the code so that you can maybe replicate afterwards. And I also, if you need, I can just send me an email. I can also email the code to you. So let's move on to the next part. Oops. Where are we? Yeah. So I have to say those contents is kind of difficult if you are very beginner for the programming. But yeah, just try to stick with the slides, and we were going to like when you meet some difficulty, you can always refer to the slides example to like modify them and then finish your tasks. So the next thing is about loop structure. So this is the final thing for the programming part. So we actually have the for loop and the while loop. And in these two loops, we are going to talk about how to control the loop. Like if we want to terminate the loop in the middle, we want to like skip some steps. So we are going to talk about some commands to control the loop. So the loop is a kind of like a repetitive cycle thing. So first, you are going to, for this for loop, you are going to initialize the expression. For example, here, we are going to test if the condition is satisfied. If it's true, then we will run this for loop body, like run some commands, and then we will update the expression, and then do another round of condition judgment, and then then if it's true, we will still go through the same for loop body. So it's more like a cycle thing. And if until it's false, so we will jump out of the loop. So this is a kind of like a repetitive structure. We try these commands for several times, and then we will move on to the next structure. So this is the syntax for the for loop. So I just give a very simple one for the for variable in the list. It will go through all the elements in the list. Here, list is actually an array, and then for each of them, we will do this this for loop body, which is the commands, and after that we have a done, which is the end of the loop. So here, I provided two things for this for loop. So this is two example that if we are going to use an array, like the second one, we can actually use a for I in this array. For each array, we will echo the element. And for the first one, it's like we simply use a string and with the spaces. And this can serve as a, if we use the for I in this string, it also will go through sample 1, sample 2, sample 3. For each time, we will echo them. So they generate the same results. So that is for the for loop. You can write a very simple for loop to go through, like iterate all the possibilities, enumerate all the choices in the array. And then there is also another loop called a while loop, which is a kind of like we first test if a condition is true, then we go through the while loop body, and then after that we test again. So again and again until it's false, and then this is the loop terminates. So this is the syntax we can use while. So this test command can give us a condition if it's true or not. So when it's true, we will do this kind of other commands until it's not true, it's false, and then this is the end of the loop, the while loop. So for example, for the while loop, I gave a similar example, but here we define a variable 5, and then we at each round we will judge if it's greater than 0, and then we echo this variable, and then update this variable. So each time, if it's greater than 0, we will minus. So this command is trying to -1 from variable. So we can see that we refer variable 1, we refer this variable, and then -1 assign it to itself. So after that, we can run it, and we can see, okay, 5, 4, 3, 2, 1 until variable is it's 0, then it will jump out of the while loop. It must be noted that you have an update of your judgment variable. Otherwise, the loop will continue to go into like it will never finish. So you must remember that you always update to make the judgment can become false. Okay. And the last thing is controlling the loop. So that is we can use a break command. So when executed, the break command will escape the current loop. For example, here, if we use very similar to the previous example, but we use the if condition within the loop, that if this variable is equal to 2, then we will break. That is, we terminate the whole loop. Okay. So after that, after we run this, we can check that okay, when variable is 5, when at the very beginning variable is 5, then we will do a -1, so it will become 4, right? Then this is not equal to 2, so it will be not the break will not be effective. So we will echo 4. So this is the output. And for another round, we -3, we -1 to be 3, and this is still skipped because it's not true. And then we echo 3. And for another round, variable become 2. And here, this one will be called because the 2 equals to 2 here. Then it will terminate the whole loop. So this break is trying to break out from the current loop. Okay, so it will only have 4 and 3 output instead of 2 and 1 in the following. And also sometimes we are facing, okay, we don't want to break from the current loop. We just don't want the current loop to continue execute the following code. So this is the example also very similar to the previous one. And we just put a continue instead of break, okay? And as we have gone through that, we analyze until variable is 2, then this one will be equal. It will continue. That means we will not run the following code here. We just enter into the following loop. So when variable is 2, it will not print out 2. Instead, it will go through another round. Variable is 1, and then echo 1. So at this part, we can see that the 2 will be skipped. We will not echo the variable to be 2 because we use the continue here. It will just terminate the current round and start the next round. So these are the two things controlling the loop we want to break. We want to just skip the current round. So these are two tricks to control a loop. So I guess I can give you guys maybe 4 minutes to practice this one. Also try to digest the previous code if you feel it's difficulty to have some difficulty to really understand it. So I guess I can show you guys how to do this practice. So we will first use VI editor to create a new file called test3. And as usual, we will put the this line as the very first line. And we want to accept this file name at the beginning. And then we were going to use parameter just to accept the parameters. And then we are going to accept the contents of this file. So we use this cat, okay? And the cat this parameter1 parameter. So in this way, this command output will be assigned to this array. And for the rest, we will go for a line in the array. So remember, this is like we are using for loop to do this, and then do if the line, okay, equals 804, 804. And then we are going to first break. So if 804 appears, then stop. So we are going to break the whole loop. So this will give an end and then echo each line. This will be the end of the loop. Yeah, I'm not sure if it's correct. We can try at first. So maybe best S3. The absolute path. Yeah, so when you write the shell script, I always recommended to use the absolute path in case you meet with some fail not exist problem or something. So we are going to use test break this file, put this file as a parameter and pass it to the script. Let's see. Oops, I think something is wrong with the script. Has to be something here. For loop. Oh, okay. I forgot to put a carry parentheses here. Parentheses, carry brackets. Okay, now it should be the same in the pattern with this. Yeah, this is how we got the how to use the array in the for loop. Okay. Now let's try it again. Still, let's see if this one. Oh, okay. Yeah. Another mistake that often occurs, that is when we try to refer a variable, we should use a $sign. Okay, now it will stop printing when we face the 804. Okay, I hope, yeah, we can just check the previous one, 801, 2, 3, 4, and 805. So when it meets 804, it will end the printing. Okay, and let's just take another look at the original code. So this is like an explanation that we use. We accept this file using a parameter, and then we try to get the contents of this file using a cat command, and then it will save the output to an array. So we will do a for loop in this array that if the line equals 804, then we will break so that we will terminate the whole for loop. Okay, and then if it's not, we will print out the line in the file. So this is basically what we did for this first one task. There are also some kind of common mistakes that is very easy to make, that we should use these carry brackets to wrap around the array. I made this mistake at the first time. And then another mistake is that I can, if we are going to refer a variable, we always need to use a $sign. So this is a mistake I made another for the second time. So I hope that when you meet some of those mistakes, you can always go back to check the slides, the example, and then try to follow that to make everything correct. Okay, this is for the first one. For the second task, we simply just need to replace break with continue. Let me do it for you here. So as we remember, the continue is simply just trying to skip the current round and go to the next round. So we can try this command, and we can see 804 is skipped. So here is what we did. Simply just try to replace break with continue, and this one will skip 804. So I hope this example can show you some usage of how to control the loop. And you can just take a screenshot of this and then replicate it on your own. All right, let's move on to the final part of our workshop for today, which is trying to use the Hofan tool. So I'm going to give you some useful commands if you are working on Hofan tool, and I will also demonstrate how to submit a single job or a batch of jobs to the Hofan tool, right? And some useful command is about module. So we know if you are going to do some computation work, especially the bioinformatics computation work, you need some bioinformatics tools there. And luckily, Hofan tool has installed a lot of tools for us. We can just use module available to check them. Probably you'll find like STAR, which is the RNA alignment tool. And also we can use the module list to check the current loaded tools on your environment. And if you really want to load some tools, you can use module load to load this one. For example, module load BWA, so which is a DNA alignment tool, something. Also, you can use a node to just get rid of it from your environment. So this is a module. And some other useful commands is about my. So my jobs will check your job status. For example, if you run it currently, you probably find, okay, there is a login node that you are using. And if you check your available storage, you can use my quota, which will tell you how many files, how many storage you have been used, and how many storage it's free that you can still use. So this is like for the ordinary user, you have this home directory and the project directory. So this is basically the output of my quota. And you also have a scratch directory. So the home directory usually is 40 gigabytes. And project directory is something depends on your group. If your group purchase a lot of storage, you probably have a very big storage there. And also everyone have a scratch directory. So this one is not backed up, and you have 2 terabytes just for your temporary usage. And so this is just like, if you don't know where is it, you can just try this command to create a directory to your home folder that you can access to the scratch storage. But make sure that you don't store your important files in this folder, in this directory, because it's not backed up. So if it's gone, it's totally gone. There is no way to recover it, okay? So, and also another thing is that the scratch directory will be, so if your files is untouched for more than 2 weeks, then this file will be deleted. So this is just a template, temporary folder for you. You shouldn't store that something is like very important. And just as I said, if you don't touch it in 40 days, it's also automatically deleted. And for more information, you can click here to check the storage for the on Hofan tool. So we have gone through this request and interactive node before. Yesterday, we talked about how to request the amount of like running time and also the memory, okay? And we also have other Q command, which is a Q sub, which is just trying to submit a script to the Hofan2, and it will do the computing for you. And then if you use my jobs, you will see, okay, there are some job ID listed there. And you can, if you don't want some job running, you can just using QDL, which will just delete the job for you. Yeah, so before I do the demonstration, I probably should go over some scripts for you that we are going to submit later. So I think this one is just like a template. You can use it, and the most important thing is just trying to understand what does it mean. So still, for the very first line, we have this pound exclamation mark, this line, just trying to tell what shell we are going to use. And there are also some other parameters here. For example, if we use this capital S is the bash, we are going to run all the commands, and we also have the this -L trying to denote what storage, what memory we are going to use, how long we allow this job to run. And we also have other parameters I'm not going to go through for very detail. So for the code, I'm just going to introduce, okay, for the first several line, we just, it's just like a login when we just see, okay, this job ID has started, this job has started, and this is the current time. And for the at the very beginning and the very end, we are going to just to record what time. And for the middle part, it's just here I just use sleep 300 seconds. So this one, it's just trying to do nothing, just hang in there for 300 seconds. So if you are going to run your own commands, do your own computing, just replace this part, and leave everything untouched. Just replace this part with your own command. For example, if you want to run some Python script, run some bioinformatics tools, just delete this line, put everything here, and then you are free to go. So this is the Q sub command we introduced before. We use it to do the to submit jobs. So here is like what I tried. And at the meantime, you can also try on your own terminal. You just Q sub this S job in D3 folder, and then after that, it will see, okay, your job, this ID has been submitted. And if you are going to check the status of your jobs, you can use my jobs, right? And then it will tell you the job ID, the priority, the name of your script, and your user, and also the state of this job. If it's QW, that means that it's in a queue and it's waiting. And if it's R, that means it's running. Okay, and it also have a submitted time here. The exact time when this job is submitted or is running. And also after that, you can find there is a job log, this job ID file, which is just the status, the output file of your job. For example, we echo this is a job, it started, and the time. When it finished, we will echo the finished and the finish time. So based on it, this is just a very simple demo example for you, but you can try on your own and check the files. So this is just a single job file, and if we want to run job file in batches, we actually can use another command called I will introduce later. But these batch jobs should be very useful for your daily computing. For example, you have 100 samples. Each of them should be aligned to the reference genome. So probably you can do like sequentially, run one by one. So, and then the total time will be like 100 times t. So t here is just like the average time that a file, a sample is processed. But you can also do it in a parallel way. That is, we run the jobs in a batch. That is, you submit the job to that, and then it will generate several computing tasks. And then the Hofan2 scheduler will distribute all the computing tasks to different loads. So this way, it will process in parallel. So the total computing time can be this way, which is just like, N here is like the number of samples that can be run in parallel. And as you can see, we can reduce the total computing time to a large extent. Okay. So this is the code to submit a batch job. You probably can find it in the D3 folder called qjob.sh. So simply this one we still have the same similar header as the previous one. And here I just simply use a job file, and then the parameters will, you can leave this two thing, this thing alone, but essentially this will just read each line of the jobs, and then it will assign to this new variable for each line, and then after that it will, because we probably have 5 samples, 5 lines in the jobs. So each time it will submit a script containing this part, like distribute, like for each sample name, it will snip 300. So probably I shouldn't put it in this way, but as you can see, this part is the same as our previous, and the only change we made is this part. So this part is just trying to, you have a job file listed in that file, and then you just take one line and then submit a job, and take another line, submit a job, but those are run in parallel. So this is what we tried. We can try that qsub, qjob.sh. So after you run that, you can see we submit 5 jobs to the Hofan2, and each of them will generate a log file. And if you just take a look at each file, you can see, okay, this is sample 1 started, and sample 1 finished, and maybe this one will be sample 1, sample 2 started, sample 2 finished. So those are just like take each line of the jobs and submit to the computing. So because jobs can contain 5 samples, so we actually will end up with I think 6 or 5 samples. So we will end up with 5 different jobs, like computing tasks running in parallel at the same time. Yeah, so basically that's what we have for this workshop, and here is just some tips for how to request resources on Hofan2, and especially how much resources you need to run a computing work. So the first thing is that you should request enough resources for your own computing job, and the one thing you need to know how many resources you need. It's simply just run one example, and then you probably have an impression, okay, how much memory should I request, and how much time should I request for each node. And also you can use this command top to check this for a single process, how much memory it consumes. And after that, you can know for like on average scale, what's the resources requirement for each task. And then you can set them correspondingly. And so I probably will leave this part to the end of the session that you can try. And there are also some common errors and solutions. Like if you are going through an error message called no such file or directory, that means it probably will have some issue with the path you use. For example, cat abcd.txt, it will run into an error. But this is because this file is not there, it's not in this folder. So one thing is that just check your file name using ls, and also just try to check the path to the file. Probably after you fix those two things, you will not see such error. Another common error is that you probably will run into the command not found issue. This is just because the command is not in the path. We have go through this before. And one thing to check is just trying to check the spelling. If the command is correctly spelled. For example, here I use a capital LS. So this one is not the small and capital LS. So it will tell you, okay, the command is not found. But if you use the original command, it will work. Another thing is that if you are using Hopfun2 to use some other software, just check that if software is loaded. So here, it's an example that I use Conda, but at the very beginning, it will tell me, okay, the command is not found. This is because I didn't load this module. So after we do that, we can actually run Conda. So this is just because the software is not loaded in the environment. And just check these two, I think most of the time, the command not found issue will be solved. So yeah, this is the end of the workshop. Actually, today we go over a lot of basics for shell programming. We talk about the variables, operations, and several if condition for loop structure about shell programming. And we also go through the examples of how to submit a single job or a batch job to the Hopfun2. And we also go over a lot of commands like qdeal, which trying to manage the jobs on Hopfun2, like qstate, try to check the status of your job computing task. And we also have this my quota, my jobs, yeah, sort of things to check the storage and things on Hopfun2. So if you successfully master what we have taught in this workshop, you are almost an expert for this Unix command line and shell programming. So this is a command we teach today. This is a short summary. I'm not going to go over all of them, but yeah. So if you are like you forget something, yeah, just go back those things and check. And let me check if there is a question in Google Doc. All right. Let me see. All right. So yeah. So the problem here for the first one is that you forgot $sign before this bracket. So if you put that, it will solve the problem. And let's move on to the second question. Right. You can also do this way. So the reason why I want to put the absolute path just outside the script is that you can always like check if you do something right. So always, because if you use some like relative path in the script, it might run into some issue. But I've always recommended that you guys put the path in the parameter things, so you can check very easily. And if something going is wrong, you can look into it and fix it quite easy. Probably I will, if you can just shoot me an email for the code to the practice, and then I will send you those code, and you can just try to reproduce what I did. So I guess that's all the question. And yeah, so another thing I want to, we have gone through this in the day one, but I still want to point out where can we get help. So, there's so many things we teach in the past 3 days, and apparently like no one is going to memorize all the things in the slides. And so you can and also there are thousands of commands there. I cannot cover all of them. So there is a lot of things that you can do on your own. Like if you are facing some computing tasks, you can always research, okay, how to do something, how to get the second column of a file using AWK. Just try to search that in Google. You probably will end up with a very good answer. And we also have this Stack Overflow Unix Stack Exchange to do that. So another thing is that still if you want to become a very proficient user for Unix command line and shell programming, you should do some self-learning, not only just to refer to the slides, but also try to look at the tutorials online. And after practicing, you probably will become a very good expert in this Unix. So for me, I learned this Unix since like 5 or 6 years ago, actually 6 years ago. So at the very beginning, I was also very felt very headache to memorize all those things, and I felt like kind of frustrated when I ran into some error. But later, after I practice and do some self-learning, I become more and more proficient in doing all those things. And currently, at present, I cannot still remember everything, but I can always try to like have a way to find out the solutions. So I think the key here is that you are not supposed to do everything correct, right? You just need to know what's the path to find a solution, and that's all for this Unix part. So lastly, I think it's a good time. It's time to say goodbye, and I think I wish you guys good luck and have fun with Unix. And also remember, don't do any heavy computing work on the login node. Okay, and that's probably all for our workshop today. We are perfectly on time. And if you have questions, you can stay here. I can solve it for you. And if you don't, feel free to leave. So the quiz will be released today, and the assignment will be released on Friday. And if you are taking this course for credit, you are required to submit those. And thank you for your guys' attention, and thanks for trying so hard to learn those things. I really appreciate that.